Problem 16. If 1100 square centimeters of material is available to make a box with a square base and an open top, find the largest possible volume of the box. So you want to maximize volume of your box. Your box has, mind you, square base and open top. What is 1100 square centimeters? It is the material to make the box. Okay, here is the picture. You want to maximize the volume function. The material contributes to the surface area. You have a box with open top and square base. Well, for any box, length, width, height, volume is given by length times width times height. But in my case, base is a square, so length and width are equal to x, the same quantity. Let's call it x, h. So the volume is x times x squared, h. Whereas the surface area, so here is my box, there is no top, but there is a base and there are the four walls. Cut along these corners. Yes, cut along those corners and the sides simply fall off. These are the four sides. So the base is length and width, length and width, length and width. That's the base. And these are the four walls which have fallen down, the height being h. Okay. So what is the total area here? Total area is area of the base, length times width, plus 2 times LH, so that rectangle, and this rectangle, L times H, and then this rectangle and this rectangle, you see, W times H, twice of that. But L and W, length and width are both x. So LW is x squared, LH is xh, WH is also xh. So in all 2 and 2, 4xh. So that is my surface area. We are told surface area is 1100 because 1100 square centimeters is the amount of material available to make your box. X squared plus 4xh equals 1100. Why is this useful? Look, we want to maximize volume. I have two variables. If I'm going to take derivative, I want only one variable. So I'm trying to get rid of one of the variables, say x, say h, okay? So I'm going to use surface area equals 1100, this equation. Solve for h, that is move the x squared over there, divide by 4x, divide the entire thing by 4x, that gives me h. So distribute the division, 1100 by 4x minus x squared over 4x. 1100 by 4 reduces to 275. X in the denominator continues. X squared and x, one of the x's get cancelled, x over 4. So that is my height. Volume formula is x squared times h. Correct? So that h is now this expression. Distribute the x squared. X squared goes to the first term, x squared goes to the second term. X squared and an x squared. Simplify. This x cancels one of the x's. I get 275x minus, that's x cubed over 4. This is my v. I want to maximize v. So take its derivative. All right. Once I have the derivative, I can now find critical numbers. Set the derivative to 0. Look, derivative is always defined, okay? I'm just setting it to 0, okay? Now, when I do that, this expression equals 0. That tells me move this quantity to the other side. Multiply by 4, that's cross multiplication. 1100 is 3x squared. Divide by 3, x squared is 1100 by 3. X is therefore plus minus. But x is side length, it cannot be negative. So x has to be positive, we take the positive root. Now look at the second derivative. So first derivative is this guy. If I take the second derivative, this goes away. That gives me 6x over 4 with a negative. Why is that useful? If I plug in this x, well, x is a positive quantity, 6 over 4 is positive, negative is negative. So overall, I'm going to get a negative sign. The point of that is, if v double prime is negative, v is concave down. That means this guy is going to give me a maximum. I hope this is clear. If my volume is concave down at a certain number, it looks like this, concave down. So that is going to be a maximum. Okay. So x, so wherever that x be, x is here. Yes. And I have a concave down situation above x. So that's going to obviously give me a maximum. So that's my x. So the required maximum volume, that's what the question is. Find the maximum volume. I plug in my x value that I have into my volume function. What was my volume function? Volume function was x squared h. H itself is all of this. So this is my volume function. So wherever I see x, I plug in root 1100 over 3. So I have this particular expression. How in the world am I going to type it in? Well, it's not very difficult if you notice something squared. So let's take small steps, right? I will first write parenthesis square power 2, and then I'm going to multiply star a large parenthesis. So I have a large parenthesis there. Yes. So now start filling in, let's say inside. This one is square root 1100 over 3. Okay, that's fine. So, so that one is square root 1100 over 3. That quantity squared, that took care of the first one. In the second parenthesis, I have first a fraction, then minus another fraction. So why don't I write that minus out? So the first fraction is 275 over square root 1100 over 3. That took care of the first part. And the second part is square root 1100 over 3 over 4. That's the second fraction. Everything is done. Include units. It's a volume. I'm square centimeters. So that tells me my units are going to be centimeters. So I should say centimeter power 3 or cube centimeters. Let's see what they accept. They accepted. All right. Until next problem, then.